my name is Oliver Swain, and I'm going to explain the problem A. Well, first of all, this is our function x to the cube, and this is, and well, we need to know the area from the function to the limit from -2 to 3. But the problem here is that this part of the area is below the x-axis, and this part of the area is above the x-axis. So when we resolve it, we have to subtract this part because it is below. And well, here as you can see, this is the area 1, the one that is positive, and the area 2, the area 1, which is negative because it is below, and the area 2, which is positive because it is above. Well, we have to integrate both of them, and the result of both integrals will be x to the 4 over 4. But the difference is that this one, the area 1, is the one that is below. We are going to evaluate them from -2 to 0, and the positive one, we are going to evaluate from 0 to 3. And well, these are the operations from when we evaluate these ones from -2 to 0 and from 0 to 3. And remember that we have to put a minus here because in this part is below the x-axis. And well, the results of both of them, well, this one is 4 and this one is 81 over 4. And for the total area, we have to add both of the results. So it will be 81 over 4 plus 4, and the final result will be 97 over 4 units of area.
My name is Rodrigo Ramirez, and I'm going to present problem letter B. So as you can see here, the function we have is f of x equals to x to the cube, and we have here the graph of this function. So in this problem, we need to get the volume bounded by the f of x, the graph, the x-axis, x equals to 0 and x equals to 3. So this is the area that we need to rotate in x equals to -3 in order to have the volume of the figure that is formed. So in order to have this volume, we need to get the two radiuses, the big radius, which is 6, and the small radius, which is 3, plus the inverse function of this one, which is, as you can see here, x equals to the cubic root of y. So you can see here the small radius is 3 plus this function. So in order to get the volume, we do pi times the integral from 0 to 27, which is this one, 0 to all the way to 27, because this goes all the way to 27. So times 6 to the square, so which is the big radius minus the small radius, which is this one, dy. So we solve these operations. We do here the binomial to the square, as you can see here, solve it, then solve the integral, and finally substitute the 27 inside each y. As you can see here, we substitute the 27, and the final result, which is a volume equals to 4,617 over 10 pi units of volume. Now I am going to explain problem letter C. We have the same function, f of x equals to x to the cube, and the same limits, x equals to 0, x equals to 3, and the x-axis and the function, of course. But now we have the line of rotation in y equals to 30. So in order to take this volume, we need to again subtract the big radius, which is 30 in this case, minus the small radius, which in this case is 30, which is all of this, minus the function, which will be this. So this will add up to be only this part. So in order to get the volume, we do pi times integral from 0 to 3, of 30 to the square, which is a big radius, minus the small radius to the square, dx. Then we again solve this, 900, and the binomial to the square, which is this one. Then we subtract and add everything, as you can see here. And finally do the integral, this one. And finally again, substitute the 3 in each of the x's. The 0 is not necessary. And the volume, the final volume is 6,318 over 7 pi units of volume. Thanks.
Hi, I'm Patika Danilo and I'm going to explain the problem number 3. That is about cross-sections, and the figure of the cross-section is a square. First of all, we need to know how to get the area of the square, that is L to the cube. Then our function is x to the cube, so we substitute the L of the function, so we have x to the cube to the square. So we have x to the 6th power. Then we solve the integral with this result. That is, this integral gives us x to the 7 over 7. So then we have to evaluate this with the limits that are 0 and 3. So then we have 3 to the 7 over 7 minus 0. So our final result of the volume of this cross-section is this fraction in units. So that is how this problem